center of mass is defined as the point at which the whole mass of a body is supposed to be concentrated. M2, that is mass of the second object, which is separated at a distance x2 from the origin, divided by m1 plus m2. By adding all the masses of the system, we will get the total mass, and hence we can write it as m1 r1 plus m2 r2 plus and so on up to mn rn. Hello everyone, welcome to session 1 of chapter 7, System of Particles and Rotational Motion. This is Swati from Department of Physics, Vidhyaashram Free University College, the Temple of Excellence, Mysuru. Dear children, let us begin with the study of System of Particles and Rotational Motion. Let us understand the topic called System of Particles. So what does it mean? Why it is that important to study about the particles motion when it is undergoing a rotational motion. So system in physics is nothing but the subject or the object which is under observation. So any rigid body which is composed of a number of particles which are having masses is called as a system of particles. So here in this chapter, we are going to study in detail about this system of particle when it is undergoing a rotational motion. So let us begin with understanding the motion and its concepts. So we all know about a concept called a rigid body. What is the meaning of rigid body? So why it is called as rigid? So rigid body is nothing but a body which do not change its size or shape after the application of external force. So the body whose shape and size does not change under the action of external force, that is called as rigid body. So what are the types of motion that a rigid body undergoes? So it undergoes translational motion and rotational motion. So what is the meaning of translational motion? It is the motion in which all the particles of the rigid body, they moves with the same velocity at any instant of time. Say for example, we have a rigid body which is made up of n number of particles and they are having masses called m1, m2, m3 and so on. So these particles at any instant of time, they all travel with the same velocity. So the motion in which all the particles of a rigid body move along the same direction and with the same velocity at any instant of time, we will call it as translational motion. Say for example, a motion of a stone drop from the height. If we drop a stone from certain height, the stone is made up of number of particles, so all these particles will be having same velocity at any particular instant of time. So, a best example to understand a translational motion. The particles which are present in a rigid body will be having a same velocity at any instant of time is called as translational motion. So, what is rotational motion? It is nothing but the motion in which all the particles of a rigid body moves in a circular path about a fixed axis. So what does it mean? It is nothing but the motion of all the particles of a rigid body. If it is undergoing a circular motion, all the particles of a rigid body having a fixed axis of rotation. So if a body is moving in a circular path from one point to another point, the rigid body's particles, the number of particles which are present in the rigid body, they'll be having a fixed axis of rotation. So the best example to understand this is the rotation of Earth about its own axis. So any body which is rotating in its own axis, the particles which are present in that rigid body will be having the same fixed axis, and that is called as rotational motion. So next, let us differentiate between the concept called center of mass and center of gravity. So what is the center of mass? So the center of mass is defined as the point at which the whole mass of a body is supposed to be concentrated. Suppose we have a body, we have a rigid body, the point somewhere where the entire mass of a body is supposed to be concentrated, it is called as center of mass. How is the center of gravity different from center of mass? So in the study of center of gravity, we must think about the concept called weight. Here we are not taking the mass only into consideration, but also a gravitational field exerts, and it is a point at which the whole weight of the body is supposed to be act. We will call it as center of gravity. We know the difference between the mass and weight. In case of center of mass, we are saying about the point at which the whole mass of a body is supposed to be concentrated, where in case of center of gravity, the point at which the whole weight of the body is supposed to be at. So the next difference between the center of mass and center of gravity is center of mass depends only on the distribution of mass, where in case of center of gravity, it depends on the distribution of mass as well as on the gravitational field. Here in case of center of mass, it depends only on the distribution of mass. In case of center of gravity, it depends on both mass and the gravitational field. So these are the basic differences between center of mass and center of gravity. So let us now move on to a derivation called expression for position coordinates of n particle system in space. So let us write the position coordinates of center of mass of system of particle. Say for example, I am considering a system where m1 and m2 are the two masses which are separated by a distance of x1 and x2 respectively from the origin. So here the expression, it is varying along x direction. The expression for position coordinate of center of mass, here the center of mass lies at this point, say for example. So that can be calculated as by the expression m1 x1 plus m2, that is mass of the second object which is separated at a distance x2 from the origin, divided by m1 plus m2. So this is the expression for center of a mass of a system of particle. So we can also write the position coordinate of two particles along x direction, y direction and z direction with reference to this. So the same way we can also write the expression for the position coordinate of two particles in space. So we can write it as along x direction it is m1 x1 plus m2 x2 divided by m1 plus m2, and since we are talking about the position coordinate in space, it will be having three dimensions, that is along x axis, y axis and z axis, and along y axis it is m1 y1 plus m2 y2 divided by m1 plus m2. Similarly, along z axis it is m1 z1 plus m2 z2 divided by m1 plus m2. So this is the expression for the two particles position in space, that is in three dimension. In general, we can explain or express this as vector r is equal to m1 r1 plus m2 r2 divided by m1 plus m2. So this is the expression for position coordinate of two system in general. So with reference to this, we have to derive now the expression for position coordinates of n number of particle system in space. Now how to represent this n number of particles in space? Like same way we can write the expression for position coordinates. Along x axis it can be expressed as m1 x1 plus m2 x2 plus m3 x3 plus and so on up to mn xn divided by the sum of masses of the particles, that is m1 plus m2 plus m3 plus and so on up to mn. So this is along x axis the number of particles which are having masses m1 plus m2 and m3 and so on. So m1, m2, m3, m1 are the masses of the particles which are present in the system, and x1, x2, x3, x4 and so on are the distance of separation of the particles from the origin of the coordinate system. And along y-axis we can represent the same as m1 y1 plus m2 y2 plus and so on up to mn yn divided by m1 plus m2 plus m3 plus and so on up to mn. Similarly, along z-axis we can represent this as m1 z1 plus m2 z2 plus m3 z3 and so on up to mn zn divided by m1 plus m2 plus m3 plus and so on up to mn. So in general we can represent it as vector r is equal to m1 r1 plus m2 r2 plus and so on up to mn Rn divided by m1 plus m2 plus m3 plus and so on up to mn. So this is the general expression for position coordinate of n number of particles in space. So what is the expression for position coordinate of rigid body? So it is the position vector of center of mass of a rigid body. So what it is given by? It can be written as vector r is equal to 1 by m integral of vector r into dm. So what is this dm? It is nothing but the whole mass of a system is classified into a small portions and it is nothing but dm. Here capital M is nothing but the sum of masses of the particles which are present in a system. This m1 plus m2 plus m3 and so on up to mn are the masses, sum of masses, and on a whole we can represent this as capital M. So it is given by vector r is equal to 1 by m integral of vector r into dm. Here dm is the mass of each element of a rigid body. If the center of masses coincided with the origin of the coordinate system, what happens? So then the position will be 0. The position vector will be 0. If the center of mass and the origin are coincided, then the position vector is 0 and this all will also be equal to 0. Since this is 0, r is 0, so the along x-axis, along y-axis, along z-axis, it will be equal to 0 itself. So this is the expression for position coordinates of rigid body. So next we have show that the product of total mass of the system of particles and acceleration of its center of mass is equal to vector sum of all the external forces acting on the system of particles. So we have to prove here that the product of total mass of the system and the acceleration of its center, that is m product of total mass and the acceleration of the center is equal to the vector sum of all the external forces. So this is what we have to prove, that we have to prove the force, the external forces acted upon a system of particles is equal to the product of mass and the acceleration of its center of mass. So let us prove this with the help of the expression already we have derived, that is r is equal to m1 r1 plus m2 r2 plus and so on mn Rn divided by sum of the masses of a system, that is m1 plus m2 plus and so on up to mn. So this can also be replaced by a capital M since it is the total mass of the system. By adding all the masses of the system, we will get the total mass and hence we can write it as m1 r1 plus m2 r2 plus and so on up to mn Rn divided by capital M. So we can multiply this with r and we can write it as mr is equal to m1 r1 plus m2 r2 plus and so on up to mn Rn. Here m is the total mass of the system we considered and r gives the position vector. m1, m2, m3 and so on up to mn are the masses of the individual particle. r1, r2, r3 and so on are the distance of separation. Now let us differentiate this above equation with respect to time. So differentiating this with respect to time, we will get m into dr divided by dt, which is equal to m1 into dr1 divided by dt plus m2 into dr2 divided by dt plus m3 into dr3 divided by dt plus and so on up to mn into drn divided by dt. Here we are differentiating the above expression with respect to time. Now observe this carefully. So this is nothing but rate of change of position. So what is this rate of change of position? It gives us velocity. Change in position means displacement. So rate of change of displacement is nothing but velocity, and this can be replaced by a term called v. Similarly, here you can observe dr1 divided by dt. That means here change in displacement with respect to time, that gives us the velocity factor. The same way here, and so on. So we can write it as mv is equal to m1 v1 plus m2 v2 plus and so on up to mn vn. So now let us differentiate this above equation with respect to time once again. So here what is v? V is nothing but dr divided by dt, what we have observed in the last session, that is nothing but the velocity of center of mass, and dr1 by dt is nothing but velocity of the first particle, dr2 by dt is the velocity of the second particle, and so on. Now after that we got this equation mv is equal to m1 v1 plus m2 v2 and so on up to m1 vn and so on up to mn vn. So let us differentiate this again with respect to time. So what do we get? We get m into dv divided by dt, which is equal to m1 dv1 divided by dt plus m2 into dv2 divided by dt plus and so on mn into dvn divided by dt. We are differentiating the velocity terms with respect to time. So what is this rate of change of velocity? We all know that velocity by time is nothing but the acceleration. So rate of change of velocity gives us acceleration. So ma is equal to m1. Here also velocity is differentiating with respect to time. We have velocity term divided by time term. So we can write it as ma1 plus m2 a2 plus and so on up to mn. So we can write this as ma is equal to, what is m1 a1? It is nothing but the force. We all know that force is equal to mass into acceleration. Since we have m1 a1, I can write it as f1. Force is a vector quantity. Similar here f2 plus and so on up to fn. So we can also represent this as ma is equal to the vector sum of all the forces, external forces that acts on a system of particle, that can be written as F external, which is equal to the product of mass and the acceleration of system of particles. So this is what we had to prove, and we arrived at the final expression. F external is nothing but the total external force that acts on a system of particle, which is equal to the product of mass and the acceleration of system of particles. So in today's session, we have learnt what is a rigid body, what are the types of motion that a rigid body can undergo, that is translational and rotational motion. We came to know that expression for position coordinates of system of particle in space, and also we derived the expression that external force, total external force that acts on a system of particles is nothing but the product of mass and acceleration of a system of particles. So in the upcoming sessions, we will learn some more interesting concepts. Until then, keep studying, keep learning all of you. Take care. Thank you.